Alright, dudes, let's get another session for. Okay, I will try to finish all the easy problems of a topic first. So, I want to get to buy, best time to buy and sell stock. Okay, so, okay. You are given an array prices where prices of I is the price of given stock on ith day. Okay. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay. So we go put 715364. Okay, so output is 5 is the maximum. Okay. Buy on day 2 and price is the lowest. Okay. And sell on day 5. Note that buying on day 2 and selling on day 1 is not allowed. You must buy before you sell. Okay. Alright, dude. Okay, so here we have it says, okay, you are given an array where price I is the price of a given stock on ith day. Price of I is the price of a given stock. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day to buy sell in the future. Okay, so profit is okay, so I want to right, I want to keep a minimum value. uh, I can okay, see, here's what I think here's what I think I can do. Here's my array. Okay, I'll keep a pointer. I'll in fact have two pointers. Let's say a selling point and a buying point. Sorry, a buying point, a buying point, and a selling point. Okay, so I have to find the minimum. Okay, I will obtain the minimum, right? Minimum from the array, uh, and I will try to find a selling point after I have found the minimum, right? I will try to find a selling point after I found the minimum. So we'll go, I'll directly say buy equals 0. So okay, so we have buy and sell equals 0 as well. Don't care about that. So I will go through the array. I'll go for I in prices, right? For I in prices. Um, uh, hmm. Is hmm. So okay. So for I in prices, for I in prices, we'll say as prices of 0, I in prices, if I is greater than by but I need the index, right? Yeah, fine. Range len of prices, then by if prices of I, okay, so we'll have min equals to prices of 0, min prices 0, and by equals 0, by is index. So if prices of, then I'll say is greater than, is less than min, sorry, is less than min. You note that, okay, same one, because that case no transaction are done. Okay, we found the minimum, then minimum, or from this minimum on to then we find the maximum. Okay, you are given in the array of stocks, you want to maximize the profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay, find the minimum, and from that point onwards try to find the maximum. Okay, let's try to do it in a simple way. First we'll find the minimum, then we'll find the maximum, and we'll provide the difference of those values. Okay, right. So I'll go with price range. Yeah, okay. If prices of I is less than minimum, then buy equals I, and I'll update prices to be, yeah, minimum. Okay, so we will obtain the minimum. This is how my thought process is going. Obtain the minimum, right? Okay, then let's try and print the min value. I have to return an integer. Let's just return 0. Okay, so nice, and here as well min. Okay, nice. Okay, min. Then I'll say, then I create another variable, max equals min. Okay, maybe I can just create minimum as a local variable. Minimum equals prices of buy. Prices of buy. Yeah, because I don't need this. Okay, buy is the day. So I think I should have print by the index, right? I should have the correct index, right? I get 0 1, yes, that is correct, and 0 1 2 3 4, right? Nice. Okay, then obtain the max from that day to uh, max from that day to the end of array, right, that day, because what I'm doing, file the file. Now I'll go and search and I'll try to find the maximum in this position. Okay, if my minimum element was this, now I have to look ahead and check what is the maximum value here. Then we subtract the 2 and that is our profit. Straightforward, fairly easy. Okay, for I in range, I'd say by it is it inclusive or exclusive? Do I need to len of prices? Okay, I don't know. It's a max, and here I want to set my variables cell equals by starting setting the starting point, setting the starting point setting the starting point setting the starting point to look for the max value. Okay, okay, obtain the max from that day to the end of array. Okay, max equals prices of cell, right? And if uh, prices of if prices of I, okay, can I query max and min? Don't I have max and min functions? I think I do. Okay, if prices of I is greater than max, then I'll say cell equals I, right, and max equals prices of cell. Now I should have my print cell. Okay, I should cell at 0, 1, 2, 3, 4. Nice. And okay, great. Then what we do is we simply don't return 0. We will return prices of cell minus prices of buy, and this should work. Set buy and sell, nice. And let's see, wrong answer. Okay, so finding the minimum, put 0 expected 2. Ooh, that means my theory is wrong. Okay. How can I check that if I look ahead? This shouldn't be the... Okay. Right. So prices. It does not really... Okay, so my assumption was wrong. Okay, let's see. Let's try and break it down better. Okay, so now okay, let's input the array 241 241. So I have to maximize the profit. Well, if my minimum is last, then it will be wrong, because then this is the profit. This is the point where I sell, buy my stock, and I get a profit of. Okay, so I have to maximize the profit. I think I've seen its solution once, and I think it uses a sliding window to maximize the profit. I think, okay. Say we use a window of size 2. What is the maximum profit here? Given this is the minimum, this is the maximum. But how would I know? Right. Did I find the max and I find the min in that window? Linear, linear, linear. Okay, here's an idea. What I can try. I will write max functions okay, max and right. Okay, hold up, wait a minute. I have this right. Okay, that's 431. I check, can I use these two? No, because this is clearly greater than this. Then we move one place and then I go here. Can I check? Can I check these two? Maximum profit. No, because this is clearly greater than this. So I move here. This is clearly greater than this. I cannot do that. And this is then 1 itself. Right. Okay. Then I move on to. So I get 1 and I and j, and both of these are correct. Sorry. And both is the same, and then I just simply return the subtraction of let's say this is buy and this is sell, so sell minus buy. Okay, simple. Then we have this case 7 1 5 we have 7 1 5 3 6 4 7 1 5 3 6 4. I start it here and here. Is I less than j? Yes. I is less than j. Then we move both the values. So I here is j is here. Is I less than j? Then we'll check is I greater than j. Then we'll move these values. Right. Let me wait a minute. Listen. Wait a minute. Okay. I'll do something fresh over here. So I have 715364. 715364. I'll choose the max. I don't have to care about the indexes. I'll say I is here and J is here. So चेंज क्या क्या करना है okay, let's continue. So I go I and J and I'll set a variable I, which is if I'd say if I is less than J, if I is less than J, then I will go with if I is less than J, then I will go with max equals J minus I, right? And then I'll increment J to look ahead. Then else if, right, else if I is greater than J, if I is greater than J, then we move the whole thing by 1. Then we go I plus plus and J plus plus. Then we check this value again. J minus I, if I is, and increment J. Okay, I'd say that if I is less than J, say if I is less than J, then max equals to J minus I, and I would go J plus plus. J plus plus, J moves here. No, okay, if I is greater than J, if I is greater than J, then I will move I. Then it will check again that if I is equal to J, then we will move J. So let's then think about it. For the first iteration, right, for the first iteration we have let me make a little 7 1 5 3 6 4 0 1 2 3 4 5. Okay, so we put I here and J here. Okay, so we'll check if is I less than or equal to J. No, it is not less than. Is I greater than J? Yes, then I move I here. Okay, so in the first pass I get the first pass I get I here and J is also here. Then I would go, is I less than or equal to J? Yes, then I have set max equals to J. Okay, max, I need to set a max. I'd say max is 0 by default. Then max, then I will check if j minus a, j minus I is greater than the max. If it is indeed greater than the max, then we will update the max. So let me write the algorithm again. If I is less than or equal to j, right? And then if I is less than or equal to j, then we'll check also if j minus I is greater than or I'd say equal to max. No, I want it to be strictly greater than max. Then I'd say max equals j minus I, and else we would just increment the I given that I, and at the end we also increment j. Okay, what is the condition? If I is less than is greater, at least it is equal to itself, then I'll move j. Okay, right now I have I and j here, and my max is 0. So I have I is I less than equal to j. Is I less than equal to j? Yes, I is less than equal to j. And is j minus I greater than the max? No, it is not. So we will not update the max, but we will update j. So now in the second pass, my I remains here, my j is here, and then we will compare again. The loop will run, and it will be like, is I less than or equal to j? Yes. Is j minus I greater than the max? Yes. So update the max. Max equals 4. Then I j. Okay, then is I. Then we will check again for the third pass. The j is there. My j is here, and then we'll say, is I less than the max? Yes. Is I less than j? Yes. Is max uh, is max 3 minus 2? No. So max remains 4. Then we'll move to 4 I, and then my I is here and my j is here, so we'll get a max of 5, and we'll return the max at the end. Okay, so now I want to tackle this problem. 2, 4 and 1. Okay, so we'll put I here, j here. Is I okay, I'd start both at 0. I guess it will be suitable to start in case of a single. What are the bounds on? Okay, it will have less than or equal to, so it can either have 0. Prices of I will be 0 to 10 to the length 10 to the 5. Okay, less than or equal to 1. Okay, sorry, greater than equal to 1 and less than equal to this. So it will have at least 1, which will be the solution itself. So I will start both at same position. Okay, then we'll go, is I less than equal to j? Yes. Then we subtract it, then we get the max, check the max. No, nothing. Then we simply increment j. Minus, yes, 2. Then we'll update max, and minus is okay, right. So let me implement the solution real quick. We'll have and I and j. Okay, I think buy and sell, it just complicates thing, but okay. So uh, I'll just go and I'll make a new variable max equal to 0, and we'll say for I in range, while I can say while j, I can just say while I think j will reach it first, while j is less than len of prices. I guess this condition is valid. J, I mean to, okay, this is a little confusing, so I'll go I and this J, easy to handle. Okay, then we'll check if prices of I is less than or equal to prices of J, then we'll say max, and if max and if prices of J minus prices of I is greater than max, then we'll say max equals to this was the thing, max equals to this, and we increment j nonetheless, and in the else part we simply increment I. I think this is it, and then we simply return the max. I think that's it, right? If I is less than equal to, then if j minus a is greater than max, then we update max and increment j. Let's try to run this program and we'll get all the solution. Yeah, okay, nice. So that is it. Not the best of solution. 67 milliseconds. Ooh, there are people with a runtime of, okay. So this is a O of n solution. If I analyze the complexity, I think, right? Analyze complexity, dude. Show your magic. O of n, yes. It is an O of n solution. Though these variables, can I do something about it? J less than the prices. If prices of I is less than equal to prices of j, right? And if prices of j minus I is greater than max, then we update the max. Increment j by 1 nonetheless, or increment I. Return the max. This is this solution is. I think this is a good solution for me. O of n solution, right? Okay, then let's. I completed it on my own, but let's see the video solution.
Hey guys, Greg here. Let's
Okay.
solve best time to sell stock, LeetCode number 121. Now you're given an array of prices where each prices at I is the price of a given stock on the ith day. And you want to maximize your profit by choosing one single day to buy the stock and choosing a different day in the future to sell that stock. So we're greedy, so you want to return the maximum profit that you can achieve from this transaction. If you can't achieve any profit, then just return 0 because you can't make any money. Okay, so if you get this array of prices here, 7 715,364. Well, you could buy it at 7, but then that's the highest price. So if you were to sell it on any of these days, well, then you're actually going to lose money. But if you buy at this one here, okay, well, you can't sell it at 7 and make 6 profit, because if you bought it here, this day has already passed. You can't sell it over here. But if you buy it here, you could sell it here to make 4, or if you bought it here, you could sell it here to make 2, or most importantly, if you bought it here, you could sell it here to make a profit of 6 minus 1, which is 5. And the max amount of profit you could get is that, which is 5. Now, before we worry about an optimized solution here, we can come up with the brute force pretty easily. You just need to look at all possible pairs of days. So we'd have to buy it at one index, which I'll call I, and we'd have to sell it at a later index, which I'll call J. And if you look at all possible pairs of I and J, then you could just try and find the maximum profit. So if you set max profit to equal the float of negative infinity, saying so far, we have not made any money at all, well, then for I in the range of the length of the prices, this is our buying point. For J in the range of I plus 1, so I is your buying index, J is your selling index, started at I plus 1 and go up again until the end here. We'll say profit is equal to the prices at J minus prices at I, so your selling point minus your buying point here. If that profit is greater than 0, then you want to set max profit equal to the maximum of itself and that current profit. You only want to set max profit to be that profit if it's better than what we've seen before. So if we look at all of these, you can almost just return your max profit, except it still could be the float of negative infinity, basically meaning that you did not find any profit. So we'll return max profit if the max profit is greater than the float of negative infinity. Otherwise, you just want to set it to 0, meaning we didn't find any profit. So we can run that, and that is going to work. However, that's not going to pass our test cases, because this has a time complexity of big O of n squared, because we have a nested for loop. We look at all of the days we could buy it, and then all of the later days that we could sell it. So that is a time of O of n squared. Luckily, it does have a space of O of 1, which is nice. However, we can do a lot better than that. So let's go visualize a better solution. Now, the idea is to keep track of two different variables. We'll call one max profit, basically the exact same thing we just saw with the previous max profit. And it's actually a little easier just to set this to 0 than to infinity. Therefore, it has a default at 0. And the other thing you'd be interested in is the minimum price that we've seen so far. So we'll just call that minimum price, and we're going to set that just to infinity. Then we're going to iterate over the array and see that we have a price of 7. Is that a better price than our min price? We're currently at infinity, so 7 is a lot better. So the next one here, we see 1. Is that a smaller minimum price? Yes, it is. And so we're going to mark that as 1. Over here at 5, that is not smaller than our minimum price. If our current price is 5, and we've already previously seen the minimum price of 1, well, then we could actually get the profit of 4. And so that profit of 4 is better than the max profit we've seen so far, which is nothing. So we should update that to be 4. Now, when we look at the next number, we see 3. Okay, well, we could buy it at 1 and sell it at 3. So that would be 3 minus 1, which is equal to 2 in profit.
Basically
well,
what
that's
I did.
not better than our max profit, so we're not
But
going to
he
use
did
that
it
one.
with
We
two
move over
variables,
and
I
see
did it
6.
with-
Okay, we could buy it at 1 and sell it at 6. So 6 minus 1 is equal to 5. That is a better max profit, and so we would mark this as a 5. And when we get to the final value here, 4, that would be a profit of buying it at 1 and selling it at 4. So 4 minus 1 is equal to 3. That's not any better, so we'd return 5. The algorithm is pretty simple. We just keep track of the minimum price we've seen and try to see if we can come up with a better profit. Okay, so the solution we'll write will have a big O of n time complexity. We're just really looping through the prices, and its space will also be O of 1. We really don't need to store any data structures. So we're going to get a min price, which is currently equal to just infinity. So the biggest value we can see. And we'll get the max profit that we've seen is currently at 0. That way, since it defaults at 0, if we actually couldn't get any better profit, then we would just return 0. Okay, then we just say for each price in the prices, if the price is less than the min price, then the min price is going to equal the price. The potential profit is equal to the current price that we're looking at minus our min price. So we'd want to buy it at the smallest value we've seen so far, and we might want to sell it at that that current price. If this profit is greater than the max profit that we've seen, then you want max profit
update.
to equal that profit. That's really all there is to it. You would return the max profit at the end, and if you're to run that, it's going to be significantly faster than our brute force solution. We're gonna fly through everything, and there you go, guys. Drop
671 millisecond runtime. I got a runtime of 67 seconds. So actually referencing, but yeah, I like to think that he doesn't have to access the numbers randomly. He is just going in a single. Okay, so we'll try to do it this. I'll just put my solution in okay, so we'll go min price equals 0 and max profit equals 0. Then we'll loop for price and prices. If price is less than or equal to min price, right? What are the values? What are the values? Price and price of 0. Okay, greater than equal to 0, less than equal to 10. Sure. Okay, if price is less than equal to min price, then I'll update. Okay, if it is equal, then I don't need to check it, right? If less than price, and then the profit will be whatever the current max. Okay, where the current profit is minus the max profit, right? Whatever the current profit is. Okay, see, here is, I'll go with 2 4 1. My profit, my max profit is 0 so far, and min price is okay. Yeah, this would not make sense for min price. I would need to min price. Okay, what is the limit? 10 raised to power 10 raised to power 4. 10 raised to power 4. What if I have a big enough? I'll start with the big enough number. So we have, then I'll check min price is 2 less than, yes, min price is 2. And what is the current? It is the current. What is the profit? Profit is current price. Sorry, profit is whatever. What is my profit? Yeah, what is my profit actually? Min price and max profit. Okay, profit equals profit minus max, but I don't have a profit right now, right? I don't know the profit, so my profit would be max profit minus min price. Max profit minus min price. So in this case, like, my profit would be minus 2. So is minus 2 greater than 0? Obviously not. So we will move along, right? We move along. Then we checked, is 4 our min price? No, 4 is not our min price. And we say profit is my profit 4 minus 2, which is current price, current profit. No, okay, I want to, okay, profit is I'm subtracting the current price minus the min price, right? Then if we check if profit is greater than max profit, then we update the max profit to profit, and in the end we return max profit. Okay, got it. And okay. Okay, this is, yeah, because it does not have to access, it don't have to access the solutions again and again, obviously. Yeah, great. So we simply checked that our profit is current price minus the min price. So if I have current price minus min price at the setting, I'll go 2 minus 2, which is what is 0, so it is not greater than 0. Then we'll have min price is 2, and 4 minus 2, which is 2, which is the maximum profit. Min price is 1, then 1 minus 1 is 0, which is not the maximum profit. Therefore we get a maximum profit like this. Okay, I will just, okay, but my solution is similar, solution is exactly the same, but it just uses these variables. Okay, the idea behind it was same. It is just the thought process of approaching a problem in a certain manner. Okay, so I can go int min profit equals to 10,000, then int max profit equals to 0, and when you go for int price, and prices will go if price if price is less than, sorry, min price, if price is less than min price, then we update the min price equals price, and then we'll go, and then I'll say that okay, it is better to put it in a bracket. Okay, then we compute the profit. Okay, and profit equals 0. I'd say that profit equals current price minus the min price. Then if profit is greater than max profit, if profit is greater than max profit, then we update the max profit equals to profit. When profit is greater than max profit, then we update the max profit, and in the end I will simply return the max profit. Let's run it. Right. Okay, great. So that is it for today.